Konnichiwa, 8th grade. That was brought to you by Hannah Williams because she's been begging for that for a while. So we'll be back to the really cool introductions for each video in the next section. But for Hannah, I had to give her a konnichiwa. So starting into chapter 3, brand new chapter, time to get a fresh start. Make sure we're getting these videos watched and getting the homework in on time. Okay, that's the biggest mistake I see people making, is not getting homework in on time. Make sure you follow the outline, follow the directions, and you'll be just fine. So section 3, or chapter 3 rather, we're going to be talking a lot about graphing, slope-intercept form, and point-slope form. So the first thing we need to do is figure out what slope is. We should already know that the slope is how steep a line is. That's something we've talked about for a while, probably since 6th grade. Okay. The formula for finding slope, we've already talked about this past chapter, is delta y over delta x. Okay, we remember that. M stands for slope, and it's the change in y over the change in x. The change in y, or delta y, is just a y value, y sub 1, minus another y value, y sub 2. The x, or delta x, is your x value, x sub 1, minus x sub 2. Okay? That's all slope is subtract 2 y values, subtract 2 x values, put them over top of each other. Plain and simple. All right? Another way to remember slope, mainly just when you're looking at graphs, is that slope can also be called rise over run. Okay, the top number tells you how much it's going up and down. The bottom number tells you how much it's going left and right. Okay? That's an easy way to remember it. Slope is rise over run. Top number y is up and down. Bottom number x is left and right. So let's check out a couple examples here. Find the slope from the given graph. Okay? So let's go ahead and take a look at a graph here. Make my xy plane. All right. We'll give us this point and that point. Okay. And so we'll connect those, straight line. And so there's our graph. All right. If we take a look at our graph, we can see that this bottom point here is at the points -2, -1, and the top point is at 1, 1. Okay. So if I want to find the slope, we said the formula is delta y over delta x, which is the same as y minus y over x minus x. So let's pick my y values. My y values are -1, -1. I took the negative from this bottom point. I took the positive from this top point. Okay. Now, since I started with the bottom point first, I also have to start with the bottom point for the bottom of my fraction. Notice I'm starting with -2 on the bottom because I started with -1 on top. Okay. So I'm going to do -2 minus 1, in which case, when I subtract these, -1 minus 1 is -2, -2 minus 1 is -3, and the two negatives over top of each other cancel to become 2/3. So our slope is 2/3. Okay. Another way that you could have gotten this is you can only do this from a graph, and that's by counting. I can start at this bottom point and count up 1, 2. That's the rise. Then count over 1, 2, 3. That's the run. Okay? That's another way that you can do it, is by counting up and over from point to point. Okay? But I would rather us get used to using this formula, delta y over delta x, because that is going to work whether we have a graph or points or whatever. All right? So that's how we find the slope from a graph. If I'm just given 2 points, it's pretty much the same thing we just did. Okay? Let's say I'm given the points 4, -2, and the points negative 7, 3. Okay? We're going to, again, we have to make sure that we start from the same point on both delta x and delta y. All right? So we'll start from the bottom point this time, and we'll start here with 3 minus negative 2. The y value minus the y value. And we can go to the x's, where we have negative 7 minus 4. Okay? When I subtract those, 3 minus negative 2 becomes plus a positive, so I get 5. Negative 7 minus 4 is negative 11. Since that doesn't simplify, our slope is 5 over negative 11. Okay, easy enough. Last example, and then we're going to talk a little bit more about what slope is on the back. Finding coordinates given a specific slope. This is where we need to know how to use the formula. Okay, I have the points x6 and 10, 3 and a slope of negative 3 over 2. And I want to, that should say, find x. Okay, let's see if I can get that changed. There we go. Find x. All right. So if I have y minus y over x minus x as my slope, I know that that is equal to negative 3 over 2. So that tells me that by subtracting the y's, my delta y needs to equal negative 3, and my delta x needs to equal 2. Okay. Well, which value am I looking for? I'm looking for an x value. So I don't care about delta y at all. All right. So all we have to do is say that if I do care about y. My mistake. I do care about y because I need to know which order they were subtracted in. So let's start with delta y. What can I do with 6 and negative 3 to get, 6 and 3 to get negative 3? I need to do 3 minus 6 to get negative 3. Everyone see that? Since delta y was negative, I needed to get negative 3. That means I started with this point first. That means on my x, I have to start with 10 first. So 10 minus x has to equal 2. What minus 10 is 2? I can go ahead and solve it. Or 10 minus what is 2? Sorry. I can go ahead and solve it. Negative x is equal to negative 8. Divide by negative 1. That tells me x has to be 8. Okay. So our 2 points were 8, 6, and 10, 3. That gave us the slope of negative 3 over 2. All right. We'll do a couple of those on homework. Now there's 4 types of slope I want to point out just real quickly. Okay. I can have a positive slope. And if I have a positive number for my slope, my graph should look something like this. Notice it seems like it's going uphill. If I'm walking up, if I'm looking at a picture and looking at a mountain, I read from left to right, so this graph seems to be going uphill because it's positive. Okay, so things like 3 halves, or 5, or 12 over 7, 3/4. Okay, all these slopes are positive, so they're going to look like they're going uphill. If I have a negative number for a slope, it's going to look like it's going downhill. So if this is my graph, my slope is going to look like it's going downhill. Okay. So things like negative 1/3, negative 7, negative 4 over 3. Okay. Anything that's negative is going to look like it's downhill. This is just an easy way to check to make sure you've done stuff right. If I get to the end of a problem and my equation has a negative slope, but the graph is positive, I know I made a mistake somewhere. Okay. Now the last two are two that people get confused with all the time. A zero slope and a undefined slope. Okay. If my slope is 0, it is going to be a horizontal line. Okay. Horizontal line is 0. Right? One way that people have remembered it is horizontal has two O's in it, like zeros. Okay? The O's kind of represent zeros, so we have a 0 slope. Okay? So equations will look like y equals 2 or y equals -3. There will not be an x term when I have a horizontal slope because my slope is 0. And an undefined slope is going to be a vertical line. So if my graph is vertical, the slope is undefined. And equations like that will just be x equals some number, x equals 3, x equals -2. Okay? Those are examples of undefined slopes. Okay? So that's everything we need to know about slopes for Chapter 3. Get some practice in as far as finding slopes and understanding what they mean and how to find them. And we'll be back here with Section 2. I'll see you then. Bye.